Hey, you tens. It's good to see you all. I'm loving all the emojis on the chats. They're amazing. Do you see me dab? I dabbed. Anna, Vic, and Kieran have just arrived. We're nearly there now, guys. Anna, Vic, we're just missing Con and Harris. That's it. Con and Harris, where are you? Emojis on the chat. I can't believe I dabbed. No, I take that back. I did that live on YouTube. Nightmare. We're missing. Where's Con? Come on, Con. Con's usually here like first. It's not it. There's Con. Con and Harris. Where's Harris? Come on, Harris. Where are you, dude? Come on. Come on. Okay, I've lost it. I've totally lost it. I'm mad. Ruby, did you just say oh no to me dabbing? Yeah. I'm cool. I'm like the coolest teacher I know. I mean, come on. Come on. Okay, I'm marking Harris is missing. He's gone. He's dead to me. Harris wasn't in the previous class, so he might be sick. Okay, cool. Moving on. Registration is done. Let's crack on. Right, guys. So we finished acid base. Whoop, whoop. Got loads of practicals to do when we go back to school. Loads of them. Dabbing is old. I'm old. Leave me alone. It's new for me, all right? Share. Let's get off this. Ugh, really? And Toby, thank you. Toby, you just got an extra mark on your next test. Well done. I am so cool. Thank you. Right, guys, we're starting a new topic today. Whoop, whoop. We are starting organics. And yes, this is part of the year 11, but do you know what? I've got 3 weeks of you guys online still. I want to see how much of this we can get done. Yeah, the more, the better. The more time we're going to have revising in year 11, and the more I can support, the more I can help guide you guys to your level 9s. I think this is going to have good value. So today's lesson, we're starting organic. I love it. Toby, thanks for the enthusiasm. Really appreciate it. That's another mark that you gain as well. That's 2 extra marks on your next test. How amazing is this? Now, you guys started GCSE in year... Wait, what? You guys started GCSE in year 9, and we learned it last year, though. Yes, Shanley, you did start learning organics last year. You're absolutely right. You started it in year 9. I don't know what year groups are going to be going back, guys. That's the problem. So let's not overthink this too much. So you guys started, you guys in year 9, you started GCSE chemistry, and you did a lot of organics, but some people weren't here for year 9, and it's always worthwhile. And plus, you guys don't remember what you did last week, let alone what you did last year, Shan. So let's start from scratch. I think that's a good idea. 3 learning objectives today. Number 1, understand carbon and its amazing properties. Yeah, sorry, I didn't add that in. I'll add that there. Amazing properties. Yeah, we love carbon. We love carbon. Oh, that's terrible hearts. Try that again. We love carbon. Excuse me? Oh, yeah, Shan. Sure. So, okay, carbon and its amazing properties. I need you to understand the term Homologous series, and I need you guys to know your GCSE families. Okay, so the word organic, this is what we need to do. Now, I'm going to start this off as if you guys know nothing. So first of all, we need to define kind of this idea of organic in chemistry. Organic chemistry. So organic chemistry, carbon comes from graphite and diamonds. Yes, Shanley, but that's not organic. You see, bit of a nightmare that. Organic chemistry. The chemistry of carbon compounds. The chemistry of carbon compounds. Everything compound. And so the first thing then to point out is a nota bene on Shan. Yeah, Shan's just mentioned two carbons, nota bene. Yeah, diamond and graphite. Yeah, we all know, thanks to bonding, that this is carbon solid and carbon solid. Yeah, well, it's a tricky thing all around. Oh, Shanley, are you looking through your notes from last year? Is that what you're doing? Good job, though. Shanley, I am so impressed that you remember catenation. Oh, Shan, I'm so proud. That's amazing. You know that most chemistry teachers don't know that word? I love that. Diamond and graphite are pure carbon. We know this. Yeah? These guys are pure carbon. What that means is because they are not carbon compounds, yeah, pure carbon / not compounds, these are they are not classed as organic. Yeah? Pure carbon, not compounds, not organic. There's my nota bene. Love my nota benes. Nota bene. Got to say it with an Italian accent. I'm not entirely sure when I know it's Latin. Because I drew a cat. That's amazing. So this is the chemistry of carbon compounds. Now, I know this nota bene here with this pure thing. I do just want to also mention a couple of other things that aren't classed as organic either. Now, people are going to say, I don't really understand why it's not. The reason I can't really tell you why. They're just not. It's because they're not. These particular compounds aren't able to form bigger structures. Yeah. So others. This is kind of a tack on here. Other non-organics include, number one, carbon dioxide. CO2 is not classed as organic. It's an organic product. Yeah, it often comes from organic creatures, but the compound itself is classed as non-organic because it's not able to form larger structures. Yeah. Other ones, carbonic acid. Carbonic acid is also classed as non-organic. Once again, because it's not able to form larger structures. So it's just nice for me to mention these two compounds because it's a very common question at GCSE. Yeah, the question would be name an organic compound, and people go, oh, carbon compounds, and the first ones that come into their head is CO2 is the most common. Yeah, so just to be aware of that. Yeah, these are not organic. Yeah, don't use these as the example. Okay, so the chemistry of carbon compounds. So what makes carbon so special? It's nice for us to pick up our element. We love carbon. Carbon atoms are amazing things. And the reason why carbon is so special is because it has some very unusual properties. And Shan has already helped us with some of those. So property number one is, I'm going to use Shan's actually. It makes 4 bonds. Carbon makes 4 bonds. 4 covalent, let's be clear on this. Yeah, 4 covalent bonds. Let's draw a picture of that. Looks like this. Yeah. So the carbon atom here has 4 bonds. I'm going to highlight the bonds in a different color. Let's do them in red. 1, 2, 3, 4. I'm going to show you another image that's exactly the same. Yeah, another picture. Oh, I'm just going to do it like this. Yeah. There we go. That is also carbon with 4 bonds. Let me highlight the bonds for you. Yeah. 1, 2, 3, 4. The fact that it's in a triangular shape rather than in like this kind of square shape, yeah, it doesn't take away that there are 4 sticks coming off it. I'm trying to think of other examples where we might see another one. There is another one that we can do. But this one's not really done at GCSE. It's not even done at A level. Yeah, I'll mention this, but you don't need to know it. This is actually technically beyond GCSE and A-level. It's not even done at A-level. I still teach it at A-level, by the way. I still teach it at GCSE, as you can see. Anyway, so carbon makes 4 covalent bonds. This is really important. There is a second point that follows on from that. Yeah? There is a second point that follows it. The bonds it makes, bonds made are very strong. And that's important. Yeah, they're very strong. Strong got an E on the end of it. Oh, strong. Oh, I've put stong. Nice one. That's why it looked funny. Are very strong. And that's important because if they were weak, then they would break and we wouldn't be sitting here today. Yeah? The next property carbon has is a really cool one. And so can I just point out, it's really lovely for me to say that Shanley has got 2 of my properties. The only one she didn't get is the strong bonds. The next one is a super cool word, and I'm going to do this one in red. Catenation. Now, this word you do not have to know. Catenation. You do not need to know this word, but I teach it anyway because it's cool. Yeah? The word catenation is a long-lost, forgotten chemistry word. It's very rarely taught. As I said, most chemistry teachers don't actually know of it. And what it means is the ability to bond with same atom. I'll tell you what, let's translate that. It means it can join with itself. It means that a carbon can join to a carbon, which can join to a carbon, which can join to a carbon, etc., etc. That there is what catenation is about. The ability for carbon to join to carbon. Yeah, ability to bond with same atom. I'll put carbon-carbon bonds. Carbon-carbon bonds. This is very unusual. Now, there are other atoms that can do catenation, but not to the extent that carbon can. Carbon can join to loads and loads of itself and form enormous chains of carbons, which is very unusual. So at this point, it's always nice to link this. So there's beautiful carbon. God, I love carbon. So if we go to our periodic, I love the periodic table. It's such a beautiful thing. It's beautiful. Hello table. It's just amazing. There's carbon. So carbon can join to itself, forming 4 bonds, and they're very strong. Wait, silicon sort of can, right? Shanley, well done, but only 8 chains. 8 chains, you mean 8 in a chain. Can you say diatomics can do catenation? No, the diatomics cannot do catenation. No, because they stop at 2, Kieran. That is not the same. I see what you're saying. I get where you're getting it from, saying that bit there, that you're saying that the diatomics are doing it too. No, that's not enough. You can't say that. Ability to bond with same atom to form long chains. Yeah, let's do an extension. To form chains. I'll put chains. There we go. Every time he pulls the table away and talks about how much he loves it. So, well done, Shan. Shan, you've just taken away my question off the chat. What's the other element that can do catenation to an actual reasonable extent? And that is silicon. Another group 4. Would anyone like to suggest another? So those 2 can. Does anyone like to suggest another? Come on, guys, on the chat. Everyone's gone to sleep on me. Come on. Name another one. Suggest another one. I do love the table, by the way, Isabel. You guys are rubbish. Come on. All the group 4s. Ashley, that's not the question I asked. I asked you to name one. Ugh. So Ashley has said all the group 4s. Germanium, tin, and lead. And the answer is no. Well done, Ruby. Oh, Ruby's just pulled it out of the bag. Well done, Ruby. There is one other that can do it, right? I need to explain to you why it doesn't happen. And the reason why it doesn't is that. So these guys here don't do catenation because they now drop onto the metal side of things. Ruby, well done. Sulfur has a minor property in catenation. It's not great, but it can do it. Well done, Ruby. Ruby, how did you know that? How did you know that? Did you remember something? You've remembered something. I know you have. What have you remembered, Ruby? I'm super impressed. I forgot about sulfur. What did you remember about sulfur, Ruby, that told you that it could? I'm super impressed. Come on, Ruby, please. Go, go, go. I'm really impressed. So silicon, we can make another nota bene. Nota bene. Silicon does do catenation, but its bonds are weaker, so can't form larger chains. There we go. I don't know, I guessed and then looked it up and it was correct. Ruby, you've remembered something there. It's because sulfur travels around as S8s. Sulfur crowns, yeah, or something at some point. Yes, sulfur is a really cool element. I actually got some wicked demonstrations with sulfur. So let's talk about sulfur for a minute. Sulfur, the element. Sulfur. Yeah. By the way, it's with an F and not a PH, just to let you know. I don't know. I remember it being mentioned. Yeah, not mentioned, meant with a T, right? Rather than an S anyway. So sulfur, often written as which is symbol, it's S. And then it actually travels around in S8s. The way I remember S8 is because I draw two S's and then I just join it up to make the 8. Sulfur travels around in 8s, called sulfur crowns, which is really cool. There's a sulfur atom. And then the sulfur atom bonds to another sulfur atom. I'm going to draw all the sulfur atoms and then join them together. You draw a W. You draw a W like that. And then you put 3 more on top as well. Like this. Right, and then you join them all together with sticks. Oh, I've missed one. That needs to come down lower. Let's lower that one. Make it look nicer. Yeah. Sulfur actually forms rings. Sulfur crowns. They're really cool things. If you're looking at this from like an angle, looking at it like this, with your eye like that. Yeah, you're looking at it kind of horizontally. Yeah, like you're looking at a piece of paper like this. The piece of paper would look like that. Yeah, if you were to look vertically down on it, you'd see a ring of 8. Yeah, you'd see something like this. You'd see a ring of 8. That's what sulfur rings look like if you were to look at them vertically down. Sulfur does some amazing stuff. And it's a solid, of course, at room temperature. Last one doesn't join. Isn't this one the one that changes color and state? Sorry, I'm late, sir. Nice to see you, Harris. I'll mark you in. Harris. I'll do that really quick. There we go. I've marked you in. Yeah, sulfurs are really cool because if you take sulfur element as crowns, which is what it is at room temperature, I did this with you guys. If you take sulfur as a yellow solid, Now, you know it's in crowns because it's yellow. Yeah, it's a yellow solid. It's a powder. You can actually get I don't have sulfur in my collection, and I've always wanted it. I'll show you what I want to get for sulfur, because sulfur's beautiful if you get an amazing sample. Sulfur element. Yeah, so I don't have sulfur in my collection, but that's because I got one particular, like, so how boring is that? Like, it looks like cheese. Like, that's not a cool sample of sulfur to have. But you can get some amazing samples of sulfur which occur naturally. Look at that. Isn't that beautiful? Crystalline sulfur. Look at that. Isn't that gorgeous? That is a piece of naturally occurring sulfur that has grown around a quartz crystal. Isn't that amazing? And it forms these beautiful geometrical crystals. But they're very difficult to come by. I've never actually seen one. But they're just the most beautiful things. That's what will go into my collection eventually for sulfur. It's really, really beautiful. It's funny because it does look like a horrible element when you just have it as a powder. It's a bit dull and boring. But these are just stunning. I can show you another thing that I really want to get. I'm going to end up with two eventually. Eventually, I will end up with 2 sulfur samples in my collection, because apparently in Java, is it Java, or it's on one of the Java? It's on one of the islands in Bali. There's a volcano that you can go up, and you can buy along the way what are called sulfur. Oh, nice one. A sulfur carving. How do you call it carving? Sulfur statue. Maybe let's try statue. And you can buy these when you climb the mountain. Let's go statue. Hang on a minute. Let's do sulfur statue. Jaya volcano. See if I can find it. I can't remember what it was called. Jaya volcano. You can walk up it in Bali, and they sell it on the side of the road. Apparently, I've never actually been. Minecraft Jaya edition. Do the crystals really hold like special energy? Do the crystals? Could you grow sulfur crystals from the powder? That's a really good question, Rue. Not really. The reason being is you'd have to vaporize the sulfur, and then you'd have to let it cool down very slowly. Is it Java? Java. Let's try it rather than Jaya. Let's do Java. Oh, I think this is the one in Bali. Ijen. It's Ijen volcano. Ijen. That's what it was. It's in Bali. There you go. It's gonna come up now. Watch. And these, I really want one. If you ever know someone who's walking up these mountains, I don't want a big one. I want the tiniest one ever to go in my collection. I'd have to put it in a box and have it sealed and everything. But they're so beautiful. Like, what the people do, they mine the sulfur from the mountain, and there are just these people on the side of the roads. I think they're probably they're just so pretty. I really want one. I need to actually just go there with one intent, go to Bali with one intention, which is to climb this mountain and pick one up. That's a long thing to do for an element. But they carve them. Oh, come on. I always find pictures of these every now and again. I don't know why. Finding it so hard now. If I do... all right, let's go climbing for Mr. Duncan. Oh, I think it's called Mount Ingen. Well done, Ashley. Ashley, do you know what? I would totally run a school. Oh, I could run a school. I could run a chemistry trip there to see volcanoes and elemental sulfur. Oh my god, I could so do that. Sulfur carving. Oh my god, I could totally do that. Oh, how good would that be? Oh my god, amazing. International Starting still not on. I know. Let's get that one. I know. Can't go to Bali and get it anymore. Come on. Show me the carvings. I've only found one image of the people who do it. Come on. They're always there. How can I not find this? Sulfur. Maybe statue is better. Don't know. I'm really surprised that I can't find more images of these people selling them. Please do that for next year. What are we doing? What are we seeing? Elements. It's not a powder. Are we going to see an element when it's not a powder? You would see crystals of it. Yeah, it will grow like this. It's not a nice place to go. There are quite a lot of hazards. The lake is full of. So this is Mount Ijen. So that lake is full of sulfuric acid. Yeah, I know, which is a bit crazy. You also get the most amazing blue oceans of fire. Sulfur is an amazing element because when it burns blue. And actually, at certain times of the year when the mountain is most active, you literally get blue oceans of sulfur fires. Now, just to give you the chemistry of that. So if you take elemental sulfur, which is yellow, and you combust it, I'm going to get rid of the 8. Now, this is an odd thing, and I'm sorry about that. You don't tend to use S8 in any equations, even at A level, because it means the equation balancing becomes a bit messy. They tend just to use S. Yeah, and then you only talk about S8 when you talk about melting points and boiling points. So you form SO2. Now this equation there is the combustion of sulfur. And the combustion of sulfur burns a beautiful blue. I think I've shown you this before. Toss in your unwanted stuff. Ooh, that's not a very nice thing to do. Come on. Looking after the environment and all that. So when sulfur burns, it burns with this beautiful blue flame. See if I can just do sulfur. It might just give me another image. Sulfur burning. It's going to give me the oceans again. And, oh, there we go. You get these beautiful blue flames. I can do that one for you in school happily. I'm sure I've done it for some of you already. But it burns a beautiful blue. It's rather lovely. There you go. And it generates SO2 gas. And SO2 gas, of course, all non-metal oxides. So this here is a non-metal oxide. Yeah. So non-metal oxide. Non-metal oxide. And non-metal oxides are all acidic. Yeah. If you have metal oxides, they're basic. Yeah. And so what then happens is the SO2 then dissolves in the water. Yeah. And it reacts with the water to form sulfurous. Careful. Sulfurous acid, not sulfuric. I wonder if someone has tried to neutralize the lake. Rue, you couldn't. It would be constant. You'd have to throw in a huge amount of limestone and just dump a ton. No, Rue, you never neutralize a lake with sodium hydroxide. You'll kill everything in it. Yeah, you'd always neutralize with calcium carbonate, with limestone, or calcium hydroxide, and insoluble. Never do a soluble base because you'll overshoot it and it'll become alkaline. You'll kill everything. So you always do it with with calcium carbonate or calcium hydroxide, either one. This is sulfurous acid. By the way, it's weak, just so you know. Sulfurous acid is a weak acid. This is what acid rain is. Yeah, this is acid rain. Thank goodness. If it was sulfuric, we'd all be melting. Yeah, so there's sulfurous acid. And that's actually what's in the lake. Yeah, the lakes that you see here, yeah, in these images, the lakes are, I've lost it now. There we go. These lakes are just high concentration of sulfurous acid rather than sulfuric. But isn't the lake like super acidic? Well, Ashley, so when we did acid-base theory, oh no, so like the stuff would already be dead. Yes, that is absolutely correct. Nothing lives in there. It's absolutely right. There were some super bacteria that live in there actually. Oh no, Ashley's not good. Ashley. Yeah, I'm not even going to mention the pH. Even though sulfurous acid, you realize that pH has nothing really to do with weak or strong acids. It's to do with the concentration of H+. So if you've got strong enough vinegar, if you have pure vinegar, it's got a pH of 0. You know, it's crazy acidic, but it's still weak. Yeah, I know that seems odd. pH and strong and weak don't really tie together very well. Spoiler for A2, year 13. Yeah. But sulfur's an amazing element. And if you guys ever come across it, you know, always buy it and always pay it back. If you ever come across a beautiful piece of sulfur, I've never seen one in the shops. I've never actually seen it. If I ever saw it, I'd probably buy one. In fact, I know I would. I really want to zoom in on that image. Yeah, these guys do little carvings. I want one of the little baby ones down here. One of those. Just to go in my collection, something pretty. But sulfur's really cool. Okay, so going back to this, we'll talk about sulfur later on in organics. But yeah, so silicon does do catenation, but it does it poorly. So okay, now that we've come across sulfur and its property, sulfur, I'm stuck on sulfur now, carbon and its properties. Yeah, we can tick that one on. Take that one off. The next one is homologous series. Okay, so this is where you're going to laugh at me here. Homo, and homo, of course, means same. Yeah, same. Logous. Now, I'm going to separate it. I shouldn't actually do that. Logous. Is that how you spell logos? Yeah, probably. U-O-U-S. Homologous. Can't remember. No, that logous. No, it's logos. No, it's not right either. O-U-S. Homologous. There you go. Homologous series. So the word logos, I'm going to separate this. I'm not going to do it in brackets. I'm going to do this one. The word homo means same. Yeah, it means same. The word logos means family. Same family. Now the word series, now you guys have come across this before. Reactivity series. Yeah. Same family. Physical properties. I know this is crazy. You guys are going to be like, what? Physical properties. Properties increase in a trend. In trend. That's what series means. Yeah. A list in order of properties. Yeah. In this case, it's size. Okay. So now what I'm now going to take, after going through all that a homologous series is, yeah, we can actually pick up some of these. And in fact, what I do want to do is just go, well, hang on a minute. There's an overarching word here, and that's family. Yeah. So in organic chemistry, you come across families. And there are many families in organics, many organic families. But at GCSE, you learn a specific set. So what we're now going to do, by the way, the word family literally means homologous series means family, but you have to use the word homologous series because it's a posh word and they want you to use it, which sucks. I'm just going to quickly tell you another question. I'm going to give you a GCSE question at this point. Question. Give three features of a homologous series. Homologous series. And the answers are kind of in the name. Yeah, it kind of comes from over here. So the answer is number 1, same functional group. Now I'm going to come to that later on. Don't worry, I'm just giving this to you now for your notes. It'll make more sense once we get to looking at our families. Same functional group. Functional group is the bit that gives it a function. Next, same functional group. Physical properties increase in a trend with chain length. Physical properties increase in a trend. Similar chemical properties. Do you know what I've suddenly realized? I don't want to put that one there. If you say the functional group gives you the properties. So you've got the same functional group. Oh, you can also have same general formula. Same general formula. That's a great one. General formula. Formulae. They have similar chemical properties. Similar chemical properties. Chemical props. And their physical props. Physical props increase in a trend. Those are the 4. Increase in trend. You have to learn 4 at GCSE. They won't take one away. They'll just ask you for 3, and you give any 3 of those. But at A level, they tend to take one of them away. They'll go homologous series. I've got the same functional group. Give 3 other features of a homologous series, and everyone goes, "Oh no, that's the one I learned." It's very common. There we go. It's nice to see a GCSE question. Okay, so what families do we get at GCSE? This is what we now need to do. So we now need families. I'm going to start somewhere else. I'm going to start down here. Family. families. Homologous series. I'm just trying to reinforce that homologous series means family. Yeah. Okay, number one, and I think lots of you can give me one of these. On the chat, please. Somebody give me my first family, the original family, please. That, by the way, if I say the original family, it means there's a definite family I'm after. Yeah, I know that you guys can probably spit out loads of families, but I want one in particular. I'm trying to filter. What is the original family? Thank you, Shan. The alkane family. Alkanes. Boom. Now, these guys are the original family. I'm going to give you an example of it. I'm going to give you ethane. Yeah. And the reason why I'm doing this is because I want you to recognize the name. Yeah. And I'm going to just go like this and underline that there. What I should actually do is color code this because I can, because my laptop is awesome. Yeah. Alkanes. Yeah. And this one here is ethane. Yeah. The family name comes in. I like it. Kieran's then given me the next ones. Yeah. So the next family. So we've got alkanes. Yeah. Family number 2 are the alkene family. Alkenes. What am I doing? Need to color code them. Gonna color code this one in green. There you go. Alkenes. There you go. Let's look at another example of this. Notice the difference. Carbon still has 4 bonds. Carbon always has 4 bonds, unless in graphite. Yeah, and this is eth. Change my color. Ene. There you go. And you can see how the names relate. The ane becomes part of the family, becomes part of the name. Seems reasonable. Oh, look at this. They're all coming out now. Family number 3. Family number 3 is the alcohol family. Alcohol family. Yeah, alcohol. Let's look at an example. Notice I'm giving you 2 carbons every time. Makes things easier. I'm going to color code, by the way. Oh, what am I doing? Why have I not color coded this? Ethane is decided by that. Ethene is decided by this. This is the functional group. Suddenly realize we can do all of this. That bit there. Oh, go back. Go away. Yeah, this bit here, the carbon single bond. That doesn't work at all. Carbon single. Single is ane. Yeah, that makes the family. This one here, carbon double, makes, this is a double bond. Double. Yeah, gives me an ene. This is the functional group. Yeah, now we come across the ol family. And I'm going to color code it. Why not? I'm color coding it. Yeah. Here's the alcohol family. This is our Friday night molecule, folks. This here is one of our faves. This is F, capital E, since I did it for all the rest. F, an, ol. And there's the ending. Alcohol. Yep, ethanol. Isn't that nice? It's cool to see how these things all link back to the original name. It's really fun. I love organics. It's my bag. Organics is my bag. My bag. No, I didn't want pink. I didn't select pink. Select purple. Oh, I didn't actually select purple. I'm sorry. There we go. Ethanol, which is nice. So we can now circle this bit here and go, there's the functional group. Yeah. Whoop. So this is O bond H. And this is alcohol group. Yeah. Double bond is ene. This is an OH. And this is ol. Ol ending. Ol. Ene. Yeah. And this is the functional groups. Right. We're doing really well. We've got 3 of our families. We're doing really, really well. Well done, Kieran. Wow. Kieran managed to pick up another family. I bet no one knows that one. That's one I probably wouldn't have done in year 9. The next one, number 4, is a new one. Well, it's not new. You guys picked it up in acid bases. Carbox. I did it all in capitals before. Darn it. Carboxylic acids. Yeah, carboxylic acid. Let's look at the example. Gonna color code it. Actually, it doesn't really work, to be fair. I need to actually color code that as well. You guys know this one. That there is what makes something a carboxylic acid. This here is F-anoic acid. F-anoic. Color code it in red. Oic acid. And you guys recognize it. It's a weak organic acid. Yeah, we know it's weak because it's organic. It's got carbon in it. All organic acids are weak. All carbon-based acids are weak, including carbonic, even though it's not organic. It's still weak, though. All carbon-based acids are weak. Okay. So we've got carboxylic acids. You realize that the only part of the name that really comes across is the acid bit. The oic is a bit odd, although the ic is there. Yeah, just the O comes in. It's a bit odd. Yeah, and there is one more. Well, number 5. Number 5 is esters. And this one, I do apologize. The ester family. The ester family is a bit more complicated. You do also have polymers, and we'll come to that in a minute, but not really a true family, so to speak. I mean, they are a family, but you wouldn't really look at it like that. Let's go for this one. And yes, this is tricky. Color code it again. That there, isn't that crazy? Yeah, they get harder. Actually, the annoying thing is this actually is a really bizarre addition by Edexcel. No other exam board includes esters in their organics. There's no point. It's actually, the next time you revisit esters is an A2. It's really stupid. Yeah, that there is an ester, and this is ethyl. I'll even color code this. Yeah, ethyl ethanoate. I'll do a whole lesson on esters, don't worry. How many are there? That's it for GCSE. That's no, I lied. There's one more, number 6. I apologize. There is another one. Yeah, haloalkanes. Shouldn't do that if I've capitalized all the rest. Haloalkanes. I should actually put haloalks. No, I'll just put alkanes because that's the only one you'll ever see at GCSE. Haloalkanes. And haloalkanes are, yeah, color code it. Yeah, halogen. This is chloromethane. Oh, chloromethane. And those are all your families. You've got polymers as well. Number 7 is polymers, but not strictly a family. Yeah, polymers, which is going to be separate. I'll do that separate, but I will still include it. I can fit them all. Yay. Those are your 6 families for GCSE, folks. Those are your 6. That's it. As I said, polymers is separate. We'll do polymers separately. And I'm going to teach you how to name all of these families. All of these families you guys need to be able to do. So I'm going to be giving, and I'm realizing that I've overshot my time, I believe. We finish at 10. What's amine? Ashley, you're looking up organic families and you shouldn't be doing it. Okay, do you want the full list for AS? And I'm happy to do this. I feel like I've just got the time now. So if you go to A-level chemistry, AS chemistry. So this is A level. Yeah. At AS, you get 10. You get alkanes, alkenes, alcohols, aldehydes, ketones, carboxylic acids, amines, nitriles, halos, halo alk, because you can get halo alkenes, alkanes, you can get loads. And number 10 is, damn it, you've broken my roll. I was on a roll. Halo, cyclos. Okay, cyclo, ... So those are the 10 from AS if you're interested. I'd love to think that you guys are interested enough to when I'm teaching you this, you'll happily ask me about the other families. And I'm also able then to give you, so I'm just going to quick, now that our lesson's over, I just wanted to introduce you to our families. And what I want to just quickly show you guys, if I can find it, that is, it would probably be in my BSKL folder, Key Stage 5. Now, guys, I don't want you to have to worry about this. Yeah. Oh, it's empty. Oh, no. Where have I put them? Chem tests? Nope. Oh, that's bad news. Where have I put them? Let's go back to all the way back here and go search for naming. Naming. I won't have deleted them. They're going to be here. Nope. There. So, okay, I found them. So, guys, these are not GCSE. These are A-level. Just going to quickly show you some. These are all the A-level. This is naming quiz number 1. Yeah, wait, what's the full of the cyclo? I'll show you now, Shan. So when you get to A-level, you pick up all kinds of new things. Like number 1, this is called a skeletal diagram. So just to quickly show you guys, in a skeletal, every joint is a carbon atom. I'll do it in red because that way at least I can probably delete it afterwards. Yeah, each kink is a carbon, and they're all single bonds. Yeah, we're not showing any hydrogens here. So this is an alkane. This is part of the alkane family. Yeah, and we need to find the longest chain. There's the longest chain, which is 6 carbons. So that is based on hexane. Yeah, this is hexane. But it has 1, 2, 3, 4, 5. It's got 5 methyl attachments. This is a branched alkane. So this is going to be a pentamethyl. Ooh, isn't that interesting? Pentamethyl. And then I need to number them all. And it's going to number from this direction. 1, so that becomes 1, 1. No, not 1, 1. 2, 2. Because that's carbon number 1. This is carbon number 2, 3, 4, 5, and 6. This is 2, 2, 3, 5, 5. Pentamethylhexane. This one, far easier. This is cyclo. Can everyone see the cyclo? It's a circle. If anything's linked in a circle, it's called cyclo. And this is cyclohex because there are 6 carbons in the cycle, but it's also an ene. So that's cyclohexene. Yeah. The next one, ethanol. Everyone knows that one. I've just done that one with you in your lesson. This one is a ketone. 6 carbons based on hex. All single bonds, it's an ane. And this family here is a ketone, got to number its carbon 3-one. That's hexane 3-one. This one is a chloroaldehyde. This is a mixture of 2. You're going to count from the carbon, carbon, carbon there. So it's based on propane. Based on propane. but it's not an ane, it's an aldehyde. So that's propan 1-al. That's the aldehyde ending, and a 3-chloro for the halogen. Yeah. Next, we've got, chlorotrifluoromethane. It's nice and easy. And then we've got, it's a carboxylic acid, guys. Yeah, longest chain. 3-methyl pentanoic acid. Next one, amines made an appearance. Yeah, this is an amine group. That is cyclo. Oh, isn't that clever? Aminocyclopentane. Isn't that cool? Aminocyclopentane. That's cool, that. There's my nitrile. There's an alcohol. There's a chloro. Let's leave all that. Anyway, let's get rid of this. Don't say. So I just wanted to introduce you to these. Now, guys, I'm thinking I should just teach you all to A-level. I think that'd be much more entertaining. It means that the GCSE becomes a doddle. Yeah, you've only got 6 families of GCSE. It's easy. I'll teach you how to name these first, and then anyone who wants the extent, I'll do extension lessons if people want to join. Guys, I'm going to leave you be at this point. Our lesson is over. I think my learning objectives, GCSE families have been done. We've covered homologous series. We've got we've even done some lovely stuff on sulfur as well. It's rather lovely. What a great lesson. Really enjoyed that, guys. Thank you. It's been really nice to see you all, as always. Right, guys, I'm going to love you and leave you. Have a great rest of your day. Have a great weekend. It's been great to see you guys. Take care.